Tesla's upcoming Bot Gen 4 and Gen 5 models are expected to feature around 50 actuators, a detail Elon Musk himself has confirmed. According to Musk, production for Optimus is already underway, and with a target price of just $20,000, he claims that owning a humanoid robot will eventually be as common as buying a smartphone or a smartwatch. It's honestly unbelievable, considering that this is a full-scale humanoid machine packed with advanced actuators, high-end AI capabilities, and an extremely complex mechanical structure. Yet Musk insists this will be the official price, promising that Tesla Bot Gen 4 will be so human-like that people might struggle to distinguish a human hand from a robot's hand. And its functionality won't be restricted to simple household chores or basic factory work. Musk says the robot is expected to gain more than 5,000 new skills and tasks next year, long before it is widely released. As Musk puts it, to complete real-world tasks like turning a wrench, threading a needle, picking up fragile objects, or even playing instruments, the robot needs hands with human-level sensitivity, precision, and degrees of freedom. This leads to the biggest question. How can a robot with this level of sophistication cost only $20,000? What exactly makes such an aggressive price target even remotely possible? Elon Musk is known for bold predictions, but even by his standards, his latest claims are extraordinary. In a recent interview, he called Optimus the greatest product ever created, surpassing even the smartphone. He imagines a future where every person owns 3 or 4 humanoid robots, similar to iconic characters like R2-D2 and C-3PO from Star Wars, except far smarter, vastly more capable, and dramatically more lifelike. These Tesla robots aren't just meant to mop floors or lift heavy items. Musk envisions them assisting in surgical procedures with precision superior to the world's top doctors. His ambition for Optimus reaches into realms far beyond basic robotics, painting a vision where humanoid robots become as common and essential as phones, ultimately resulting in billions of units worldwide. Instead of being luxury gadgets, they will become practical assistants, helping raise children, walking pets, running errands, chatting like companions, or even offer emotional support. Musk predicts that in workplaces, each human could be paired with 3 or 4 robots, pushing global robot numbers to 30 to 40 billion in the coming decades. For Tesla to offer Optimus at around $20,000, Musk says the company needs to reach a massive scale of at least 1 million units produced per year. Although industrial robots are typically extremely expensive, Musk insists that Optimus will cost half as much as a Tesla vehicle due to rapid innovation, vertical integration, and shared engineering across Tesla's ecosystem. Each robot requires about 100 actuators, most of them packed into the hands and arms. Musk refuses to simplify the robot's hand because the ability to manipulate objects as humans do is central to Optimus's usefulness. He has repeatedly explained that the hand alone represents more than half of the robot's total complexity. A proper robotic hand requires 5 fingers, joints with varying lengths, distributed flexion systems, and a forearm packed with artificial musculature. It must be capable of holding a fragile item one moment and lifting heavy weight the next. This level of engineering demands actuators that are compact, durable, powerful, and incredibly precise. Without such a hand, Musk argues, Optimus cannot meaningfully participate in the vast number of labor tasks Tesla envisions, tasks that could revolutionize access to material wealth without exhausting global resources. In Musk's imagined future, robots could construct homes, build infrastructure, or complete sophisticated architectural projects for anyone who needs them. Healthcare is another area Musk highlights. With consistent precision and no fatigue, Optimus Gen 4 and Gen 5 could perform complex medical procedures with accuracy surpassing humans. Since expert surgeons are limited by training and physical endurance, Musk believes robots will help close critical healthcare gaps worldwide. He often points out that all the core technologies needed for Optimus have existed within Tesla for years. He claims every Tesla vehicle is essentially a robot on wheels, equipped with batteries, power electronics, motors, gears, vision systems, customized AI chips, advanced software, and massive fleet-scale autonomy experience. Musk says that transitioning these technologies to a humanoid form gives Tesla a huge advantage, making it the world's most capable robotic manufacturer. The biggest challenges, he says, are mastering the arms and hands, deploying real-world AI safely, and scaling production. areas where he believes Tesla outpaces competitors like Boston Dynamics and Figure AI. Optimus is currently in version 2.5, already able to navigate independently, recharge itself, and perform simple tasks. Musk says Optimus 3 will be such a leap forward that it will look like a person wearing a robotic suit. It's scheduled to appear in early next year's demonstrations. Gen 4 is expected in 2027, and Gen 5 should follow in 2028, with each year bringing major upgrades. More shocking is Musk's claim that Gen 4 production could reach tens of millions of units, and Gen 5 could scale to hundreds of millions. Though these numbers sound extreme, they match Musk's broader vision for near-universal robot adoption. According to Musk, a humanoid robot doesn't suffer the limitations of biological workers. Humans work roughly 1,800 to 2,000 hours a year. Robots can work 24 hours a day, totaling 8,760 hours annually. Even with occasional maintenance, a robot easily outperforms a typical worker by 5 or 6 times. And unlike humans, robots don't lose focus or precision. For delicate work like surgery, cleanroom manufacturing, or hospital duties, this consistency is invaluable. Safety, however, remains Musk's highest priority. Tesla wants robots that can operate around humans without risk, building toward a future where robots take on physical labor while humans pursue creativity and personal fulfillment. A major priority for Tesla remains home usefulness. People will only accept humanoid robots if they can reliably cook, clean, organize, and handle daily tasks. For decades, such household robots existed only in science fiction. Preparing food, making a sandwich, or retrieving items from a fridge requires sensory intelligence and delicate hand control, abilities robots historically struggled with. If Tesla can maintain a $20,000 price tag while offering a 50-degree of freedom hand, consumers will soon face a choice. Wait for Gen 4 in 2027, or purchase the Gen 3 model arriving next year. For many potential buyers, the decision will come down to how rapidly Tesla can refine Optimus into something that truly moves like a human and performs tasks with natural ease. Gen 3 already shows surprisingly fluid motion, occasionally fooling audiences into thinking a person is inside the suit, and each demonstration reveals how quickly the technology is maturing. By the time Gen 4 arrives, the line between human and machine may blur even further, pushing Optimus into a category of robotics that once existed only in movies. Whether people choose to wait or jump in early, the coming years will mark a turning point in how society views intelligent machines, and Tesla seems determined to lead that transformation with relentless speed and ambition. Optimus Gen 3, priced below $20,000, is officially scheduled for release in the first quarter of next year. Meanwhile, Tesla has already laid out a clear roadmap for generations 4 and 5, each bringing major design refinements and human-like agility. Musk has even revealed a specific rollout order. When Optimus 3 appears, he says it will look so natural that you might mistake it for a person in a robotic suit. Production for Optimus 4 is projected to begin in 2027, followed by Optimus 5 in 2028, establishing an annual upgrade cycle with huge leaps in capability every year. This naturally raises big questions. What tasks will each model handle? How much will they cost? And why is Tesla focusing first on homemaker duties and surgical precision roles? Musk believes the scale of the Optimus project will be unlike anything humanity has ever seen, calling it the largest project of all time, potentially surpassing the impact of smartphones. At the 2025 Tesla shareholders meeting, he announced sweeping updates and future plans for Tesla's humanoid robots, suggesting that Optimus could become more common than mobile devices and might even contribute to reducing global poverty through the value of its labor. Even at this early stage, the Tesla bot already operates with full autonomy, performing caretaker duties, indoor chores, package delivery, plant maintenance, cooking, object retrieval, and deep cleaning tasks entirely on its own. Musk claims Optimus can do almost anything: walk pets, handle babysitting, mow lawns, and even participate in emergency rescue work. The commercial Gen 3 model will ship with about 1,500 practical tasks installed and grow to 3,000 tasks through free updates. Gen 4, however, is expected to be far more capable, nearly twice as intelligent as its predecessor, with around 5,000 usable tasks. By the time Gen 5 reaches consumers, the task library may expand to an astonishing 6,500, transforming the robot into something close to a precision-engineered miracle. Musk reiterated that the engineering of the future will be carried out by machines like Optimus, not by human hands. Leaked footage of Optimus 2.5 has shown it balancing under impact, manipulating objects with surprising finesse, sorting items rapidly, and learning new actions through simulation. These hints reveal just how advanced future models will be, as engineers continue refining the design to hide nearly all visible wiring and joints. Musk also noted that the robot's movement quality will become so natural that it will be almost indistinguishable from a human's. Gen 4's hands are set to offer much higher dexterity than Gen 3, enabling fine detail tasks like assembling tiny components or manipulating delicate materials. Its hands contain miniature actuators that allow for up to 22 degrees of freedom, bringing biomechanics to life in a way previously unseen. Through intensive training, the robot learns object functions, storing this information in its AI brain to make rapid and accurate decisions. Using cameras and 3D sensors, it recognizes objects not only by appearance but